Hello, my name is Fran, and today's question is a pH calculation after partial neutralization. You may want to stop the video, see if you get the answer. If you do, great, well done. Then maybe you want to try the stretch and challenge question that you will have here at the top. And if not, we'll go through it together. First thing is, even if you don't have a clue about the question, if they give you the volume and the concentration, calculate moles. That's going to be a cheap mark to get. And because you have to do it twice, 2 marks. Not too bad. And then to get the remaining 4 marks, you need to have an idea of what this question is about. So it's a strong acid with a strong base neutralizing each other. Thing is, one of them is going to be in excess, it's going to remain. How do we know that? Well, if none of them was in excess, then the final pH would be 7, which then they wouldn't ask you to calculate it. So what will happen is that you have to find the pH of the final solution of your strong acid or base. And the first thing in any chemical calculation is to write the balanced equation. This is chemistry, it's not maths. With the balanced equation, we get the molar ratio, which is really, really important. We are going to calculate which reactant is in excess. And you may think, well, sodium hydroxide has fewer moles, therefore, surely that's not the one in excess. And you would get it right, but just by luck. To calculate it properly, you have to do this calculation. We know the molar ratio. Let's pick the moles of sodium hydroxide. Sorry. So this would be the moles of acid that would react. Now we compare what we have present of sulfuric acid with what we need for all the sodium hydroxide to react. And we see that we have more than the amount that will react. Therefore, sulfuric acid is in excess. You could do the same calculation starting with the moles of sulfuric acid. These are the moles of sodium hydroxide needed to react. So now you compare what you've got present in solution, that you calculated at the very beginning of this question, with what you've got, with what you need. And you will see that you need much more than what you have. And therefore, sodium hydroxide is the limiting reagent that you will use for further calculations. Sulfuric acid is in excess. Next thing is to calculate how much sulfuric acid is going to stay in excess unreacted. To do that, we do an ice table. Ice, which means initial amount, change, or the amount that reacts, and end. Because we know sodium hydroxide is the limiting reagent, then all of it is going to react. Now we use the molar ratio to see how much sulfuric acid will react. And then you do initial amount minus the amount that reacted. And that will give you this. These are the moles that we have after the neutralization has happened. That's why we call this partial neutralization. And the total volume, which is going to be the volume of sulfuric acid plus the volume of sodium hydroxide. And therefore, again, you can calculate the concentration of sulfuric acid in your final solution after the reaction has taken place. The last part of this question is to find the pH of your final solution of sulfuric acid, which is a diprotic acid. By diprotic, we mean that it has 2 protons to give away, as it is shown in this equation. 1 mole of acid gives you 2 moles of protons. So initially we have acid, then all of it dissociates because it's a strong acid, and therefore you will get double the amount of protons. And from here, then you do the minus log of the concentration of protons, and that is your final answer. So you can see that this question had a lot of layers. Hopefully it makes sense. If you have any questions or any comments, any feedback, and you would like to share it, you are more than welcome to do so. This is all for now. Bye bye.